Hello, so this is a revision video for IB Chemistry S2.2.11, Resonance Structures. This is only for AHL students. Resonance structures are different valid Lewis structures for the same molecule or ion, where atoms are in the same positions, so bonded in the same arrangement, but electron pairs, especially from double bonds, are in different positions. Different resonance structures represent the same molecule or ions, not different forms, and the actual molecule is a resonance hybrid of all resonance structures, meaning the bonding that actually arises is a mixture of the different possible forms we can draw out. Common examples you should be aware of at this level include ozone, carbonate ions, and benzene. Ozone molecules, O3, are made up of 3 oxygen atoms bonded together. If we label each of the atoms as A, B, and C, we can see that there are 2 different Lewis structures we can form. One with a double bond between the oxygen atom A to oxygen atom B, and a single bond between oxygen atom B and oxygen atom C, and another valid structure where there is a double bond between oxygen atom B and oxygen atom C, and a single bond between oxygens A and B. Now, the actual structure of ozone will be a resonance hybrid of these 2 structures, where the double bonding electrons from each are actually spread out across the 3 oxygen atoms. As a result, all the bond lengths in ozone are equal and have the same strength. Whereas if there were actually single and double bonds, we'd expect different bond lengths in the molecule. A carbonate ion, CO3 2-, is made up of 3 oxygen atoms bonded to a central carbon atom. If we label the oxygen atoms in the same way we did with the ozone molecules, we can see there are actually 3 ways we can represent the bonding in a carbonate ion, with a double bond between oxygen A and the carbon, a double bond between oxygen B and the carbon, or a double bond between oxygen C and the carbon, with the other oxygens having single bonds and a negative charge each. In reality, the pi bonding electrons from the double bond will actually be spread out and delocalized across all 3 oxygen atoms bonded to the carbon, meaning the resonance hybrid would show this delocalization, and all carbon-oxygen bond lengths in the carbonate ion will be the same and have the same strength, and this is what we see with experimental data and measurements. Benzene C6H6 is a molecule made up of 6 carbon atoms bonded to 6 hydrogen atoms. We can show the bonding between the 6 carbon atoms as being a ring with alternating single and double bonds. Now, there are 2 ways we can represent this alternating single and double carbon bonding, but in reality, the actual resonance hybrid of benzene will have a delocalization of all of the carbon double bonding electrons. This resonance hybrid is referred to as the delocalized model of benzene, and again means that all the carbon bond lengths in benzene are equal, giving benzene a perfectly hexagonal shape. It also gives benzene some interesting chemical properties which are covered later in this course.